Let's start with homework questions, just so if they have homework questions, they can look at something to see. Anybody have a homework question you would like me to go over? What do you got? Can you tell me what it says? Anybody have it already? Y is what? Comma negative 1.1. And we're turning it into polar. Okay. So we're going to turn this into polar. So remember, polars in terms of, right now we're in rectangular. By the way, this is actually a great question on your test, is something like this, taking a rectangular point and moving it to polar. Okay. So once again, let's just kind of graph it so we know where we're at. That's down here, isn't it? Where our x is negative 2.5. Our y is negative 1.1. Any questions on how I have those values? Okay, with that being the case, we did good old Pythagoras, which is 6.25 plus 1.21. Take the square root of 7.36. Is that a perfect number? Can anybody just tell me what it is, since they're already in decimals? You're going to need your calculator, so if you guys have them, get them out. Our whole lesson's basically on calculators today. Huh? 2.71. Thank you. So there's our radius, right? We already found that because a squared plus b squared is c squared, or x squared plus y squared is r squared. Remember how we found that? Pose? Feel good there? Okay, 2.71. All right. Now, if you recall as well, Cosette, I could actually use any of my trig functions. I'm going to use tangent because tangent always uses y over x, and that's what a coordinate point is y and x, right? So therefore, I know the tangent of theta is the y, so negative 1.1 over negative 2.5. I would like you guys to do the arc tangent of 1.1 over 2.5, please. Somebody help me out. Anyone? What do you got? If you'll put it into radians, anybody have it in radians? 0.414. Do I got a second on that? Okay. 0.414. Okay, so notice though, that puts me up here in quadrant 1. And that makes sense because the tangent of opposite numbers should be in quadrant 1, but it's also in quadrant 3. So what I do is, remember, that's the reference angle, so I'm going to put here 0.414, right? What do we know from here to here? That's pi, right? Plus 4.414, so I have 3.14 plus 414 is 3.554. Does that make sense, Cosette? So the first one is my radius, the second one is my angle. Is that good? Okay. Any questions on that? Definitely a great question for the test. Okay. Anybody else? Okay. Yes, ma'am. Just because you asked. I'm ready. Polar. Same kind of idea. So negative 3 up 4. So here it is. But I'm going to draw a triangle. I want to know this angle, but notice we already know this is 5, right? So our radius is 5. Okay. Notice going to use the tangent again because that's the y over x. Go ahead and take the arc tangent of 4/3, negative 4/3. It is. That's exactly. I'm going to explain it. So is that what it is? Negative 0.92? Okay, but notice that's down here, right? Which makes sense. Hey. But notice, once again, that's where tangent's negative, because remember the inverse tangent is always between negative pi halves to pi halves. So that's why it's putting us there, but what quadrant am I in? So then I'm going to use that as that reference angle of 0.92, right? And how much is this again? Pi cut back 0.92. So that's 2.26. Or no, you said 0.92, right? 3.14 minus 9.222. Is everybody with me in understanding how you find that? The key thing is just remembering reference angles, reference angles. Every time this comes out, it's a reference angle, right? Where's that reference angle? Am I in the right quadrant? No. So therefore, if I am, like if I did the arc cosine of that one, it'd put me right where I need to be. Do the arc cosine of negative 3/5. And I bet it'll give you 2.22-ish. And the reason being is, if you recall, the arc cosine, remember its restrictions was between 0 and pi. So it gives us answers anywhere between there, right? The arc sine and arc tangent put it in quadrant 4 and quadrant 1. You guys remember that when we did the inverse tangents, how it was only a function in between those two places? Okay. Anybody else? Do we do okay? How about the different locations? Do we do all right on that? All you really have to do is think about, like, let's just do one. Can we just do one? Anybody have one that we could just go ahead? 4.71. All right. So a couple ways to do this is, first off, you always want to graph it. You want to kind of get the idea of where it's at, right? Well, that location's down here. Well, yes. Let me think. Ooh, can somebody tell me what 3 pi divided by 2 is? That should be like 4.71 exactly? Oh. And it gave you 4.71, not the 3 pi halves. Interesting. Basically, it's right there. Right? Very close to the axis, because obviously we're extending. This one stops so close that it almost looks like it touches. You with me there, though? We could even call it root. We could call it 3 pi over 2. But in that case, what do we know about this distance? How much is that? 2 pi, right? So therefore, if I know this one is 4.71, I could go 6.28 minus the 4.71, which is 1.57. With me? I could say this is 2 root 2 comma negative 1.57, because then I'd just be going backwards. With me there? Or I find this angle, which is the 4.71 minus pi, which is 3.14, right? You with me there? So that angle is 1.57. So that's up here, but then if I push through, it gets me through. So it'd be negative 2 root 2 comma 1.57. With me? Or what else could I do? Just take this answer and either add or subtract 2 pi, right? You guys with me on that? Yeah. If I add pi, that would get me there, but that doesn't always happen, though. In this case, it did, but not always. So just be aware of that. Well, if you add pi, that should be pi, because it's, never mind, that does work. Yeah, because that pushes us through. Yeah, good job. Because that'd be a half a circle. Yeah. Yeah. Good job. Just didn't think deep enough about it. You killing cheetahs again. How many cheetahs you got in your house? You guys just grow them so that later you can use them for clothing? Like, are you Cruella, but of the cheetah world? I would like your cheetah puppies. Anyway. Anybody else? We good? We ready to rock today? Yes. Yep. Yeah. So if your radius is 0, right, it's always going to be at the center point because it doesn't matter what angle, it's always going to be there because your radius is 0. Now, if your angle is 0 and your radius is different, then it just goes further out. Yes. Well, so we're going to go 2 square roots of 2. So let's go ahead and plug that in our calculator. Get an estimate, right? Okay, 2.8. So here's 3, right? Then we go, was it 4.71? So it's down here. We just get somewhere out there. I mean, we're estimating, so it's not perfect, but you got the idea. Okay. All right, should we do the lesson today? Okay. So the lesson today is 8.1 and 8.2. 8.1's mean, median, mode. Hot dog, you already know about this, right? But we're going to use some data just so we can showcase it. I would like everybody in this room to share their shoe size with me if you feel comfortable. Ladies, I'm going to ask you to subtract 2 from your shoe size so that we're all in men's sizes, if that makes sense, so that we're comparable. Is that okay? 2 from your size. So I am an 11. Nay, what are you? Sure. She's a midget. Benny, an 11. Caden, Camden, sorry, 9.5. So we're just going to round up. So here he's going to be a 10. So if you're a half, just go up to the higher one, okay? Probably in a 12 with that. Oh, Cliff, 11. Midget woman again. 10. 10. Back in the back, purpley hat. Yes, you. I forgot your name. Tell me your name again. You were in my class last year. Jacob. What was your last name, Jacob? Jacob Johnson. Jeremiah Johnson. Oh, I love Jeremiah Johnson. We might even have to go look at Jeremiah Johnson. He's so damn cool. You guys ever watch Jeremiah Johnson? Jeremiah. It's okay. They need to look at Jeremiah Johnson too. Ugh. Images. Yeah. That's such a good show. I'm a strong man. Yes. Yes. Anyway, that's this right around there. I wonder if there's GIFs. Is it GIFs or GIFs? Oh, not gig. Yep, that's the smile. Well, I didn't do anything. Oh, we're not going there, it looks like. Anyway, we'll go back. Okay. Thanks, Jacob Johnson. Yes, Mr. Sir. Mr. Dude with the Diet Coke. Your shoe size. It's not a hard thing, guys. Another midget. Holy moly. 7. Jazz. 11. Jade. You guys should be writing this down. If I write chiz down, you write chiz down. And Carter. Carter with the Bigfoot. All right. So last class, we had a guy, that's a 5, by the way. the 5. It's the 5. All right, that's why you two don't get to sit by each other. So, as we go through this is actually pretty well rounded. It's pretty good numbers. Last class I had all about this, and then I had size 16. Okay, which really didn't skew our data too much because we actually had a 14 and a 13, so really it didn't skew our data. Let's say Shaq just walked in here though. Okay, Shaq's like trying to get through our door because he's a behemoth of a man, and his size 28. I don't know really what he wears, but let's say he has a size 28. Let's look up it. Shaq's shoe size. No, come on now. $23. But still, even if I threw a 23 out there, that's pretty big, right? So what if Shaq all of a sudden walked in here, he's a 23. What do we call that number? He's an outlier because he would skew our data, wouldn't he? Right? Last class, when all the sophomore left, I only had one girl in here. So our data was 10s, 11s, and then a 4. She would then be considered an outlier. But then I started getting some other of the ladies that I'm like, oh, then I'll do the whole class instead of just my class people, if that makes sense. You know what I mean? So then there were some other females in here. So then that started making the data be a little bit normal because there was other shoe sizes coming in. Does that make sense? How are you today? Just fine? I'm fine and dandy. That didn't go very far, Alex. That's you. Huh? No, we're not. I just wanted to talk about what an outlier was. Shaq would be an outlier, right? And what does outliers do? That skews our data, meaning our average would be larger than it would normally be, right? Does that make sense? Yeah. Is everybody with me on that? Understanding what's happening? Okay. I just really wanted to hurry and talk about that. But right now, we're actually going to go ahead and find the mean, median, and mode of this data. Now, I could do this by hand. Wouldn't be hard. But we have technology. Okay, and with this stuff, let's use technology. So really quick, though, let's talk about the names of these, just for those that might come from Germany and doesn't know mean. She's not because she's testing. Hence why I'm doing this for her. Mean. Another name for mean is average, right? I don't know why we call it a mean and not just an average, but what is an average and a mean? We add them all up, divide by how many there are, correct? Pretty simple idea of what's happening. Okay, what's the median? It is the middle. Okay, so let's talk about it. We have two different types of median, though. We have when there's an odd amount of elements in there, there's a distinct middle number, isn't there? Okay, but when there's an even amount, is there a distinct even number? So what do? They take the average of the two innermost. Does that make sense? Okay, and then mode means most. I like to just put more because then I change the D with the E with it, you know. Now, there's two things out there, and it depends on who you talk to. Some statisticians say, well, if there's more than one, if there's both, okay, let's say, for example, size 11 came up 7 times and size 9 came up 7 times. There's two numbers that happen the most, right? But really, did they happen the most? Because it's not more than another. You know what I mean? Definition of most is the most. I don't know how you say it, but you get what I'm saying. But definition with the word in it, that's always a great definition. But you get what I'm saying. To me, most means the largest, or the, I don't know how to say it without saying most. But you get what I'm going at. So some people believe that if there's more than one, there isn't a mode. But we're going to go with that, whatever it is, if it's like 7 and 9, I mean 11 and 9 would use both of those. Does that make sense? So just understand, though, I want you to understand that there's differing ideas. Okay? You good? That was like a dirty look for a minute. To the machines! Hopefully you guys have this written down because I need somebody to tell them to me. Here's what we're going to do. Okay? We're going to hit stat. Do you remember how to get into where you need to go? Okay. So you're going to hit stat, edit. Now, right now, this was last class's period. Okay, but I want to clear that. So I go up into L1 and I hit clear. Do not hit delete, hit clear and enter. Another way to do that I'll show you is stat down to clear list. And then I come back to the main screen and I hit L1, which is number 1 right there. Everybody with me? If you had information in there. Good? Okay, so I'm going to go back to stat, edit. I'm back there in L1. You should put your data in the far left corner. Understand if somebody might have deleted it. Do I have any 83ers in here? Which is fine. Just understand I would have to help you. Look at it, make sure you're in L1. If it's L2, it's fine. I just got to show you what to do. Okay. You done already? What did he have you do? Which one is it? What for who? It's because I'm not here, huh? Okay. Anyway, let's read through it again. Can somebody, as we enter it, can somebody tell me the numbers? Please, can somebody be my designated person? Ash, do you mind? Go ahead. 11, 5, 10, 10, 11, 3, 4, 7, 6, 11, 11, 4, 7, 5, 5, 9, 5, 11, 12, 11, 7, 11, 11, 9, 6, 13. All right, so it looks like we had 30 members in this class right now. There's 30 people in here, okay? So when our median, what would happen in our case, because it's even? They'd look it up. Now, the nice thing is, how many of you guys hated putting them in order, right? Well, that's what this lovely machine's for too. Watch what will happen. I'm going to show you. So if you go back to stat, you see number 2, it says sort ascending. We want to know what list we're ascending to. We're doing L1. So it can sort it for us, and then watch as I go back in. It's already there for us. Kind of nice, right? Everybody there with me and understanding how to do so. All right. Okay, cool. Well, what we need to do is find mean, median, and mode. Mode you can't do on a calculator, not unless Jazz's does it. I don't know. I know ours doesn't if you have a TI. Okay. So let's quickly look at our data and just pick which one has the most really quick. I think 11 happens. Let's count that just to make sure though. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of our 30 was an 11. All right. Anybody else see something a lot? 5 happens 4 times. I think 11 is going to be it. 11 would be our mode. Any questions on how we found mode? Pretty simple, right? All of these should be simple for you. How many of you guys have not heard of mean, median, or mode? Let's make that clear. I don't think anybody, you should have seen it. So let's look at our median. Here's what we're going to do. Go back to our calculator, hit stat, calculate 1 varstat. Now I Googled it just a minute. If you want to come up, I can look for it. You know how to do it? Come on. Did you get your information in at least? Okay. If you hit 1 varstat, now this is the place that you need to understand. Where did you put your data? Mine was in L1. If it was in somebody else's, this is where you would switch this. Now, if you are in a TI-83, you don't come up with this chart. It just goes back to your main screen, didn't it? Just make sure you type in L1. So hit second, number 1. So So we were there. Then exit. Stamp. Test. Calculate, I think. 1 bar. That's what our data is that we're doing. So then you go there and you should have the same stuff. Okay. See how I'm hooking you up? Okay, so we have all this data. X bar on the very top. X bar represents average. X bar means average. Then it has the sums of x's, the sums of x squareds, all that stuff, because that'll help us with other stat stuff, but not right now. Then they have the S of x and the sigma of x. Those mean something that we're going to talk about in just a minute. We'll come back to it. But if I scroll down, my median is what? 9.5, and the reason why it's a 0.5 is because, once again, it was the innermost between two terms, wasn't it? Because we had, none of those sizes had a half, so therefore it had to be the average of the two insides, which would have been a 9 and a 10, right? Did you get that data? You good? Where are you confused at? Your list you might have entered something in wrong. Hit enter. Yep. Did it pop up? If you're not the same, yours might have 8.3 on top. Does yours have 8.3? Yeah, it's just up here. I just scrolled down. See my med? My med is median. And you guys remember what min x, quartile 1, median, quartile 3, and max x tells us? Box and whisker. We're going to be doing that in just a second as two. So let's try and write those numbers down so we don't have to come back to this. Min 3, max 13, quartile 1, quartile 3, and the median. Luckily I didn't punch it in, huh? Huh? Were you on your phone? There we go. Were you on your phone? There's the reasoning. You're next. That was a pretty good throw though, come on. I didn't mean to hit you in the head though. It just sometimes that's a big thing and just hits it. I did shoot a kid in the eye with my Nerf gun yesterday. He's like, this is really what he did. He's like, all right, Roberts, wouldn't it be cool if I could just catch it, you know? So I'm like, so he had it right here. So I'm like, all right, I got to aim for it. Anyway, it went right through his triangle and hit him square in the eye. It was so funny. Hi, how are you? Good, how are you? Lift, you're up. You didn't put in a class either, you did, Barry. Are you TAing for Bastion too? Anyway, okay, so we have all this information. Let's go back to our stuff. The average, once again, was 8.33, right? Is everybody with me on that? The middle was 9.5. We found the mean median mode. Could I do those without having to do the calculator? Would it take some time? Yeah, I just got to add those up, divide it by 30, because I think there was 30 of them, right? And then how would I do the median? I have to line them up numerically, don't I? Okay, numerically. Okay, nice. Now the next thing, using that same data, we're going to do a box and whisker. So let me just draw in general a box and whisker. Here's what it looks like. Now let's talk about what each of these things represents. This represents what? The min. Oh, I forgot to talk about interquartile range. We'll get to that in a moment too. I don't know if that's on our test. I can't remember. This is quartile 1. What's another name for quartile 1? The median between the min and the median. Because you're finding the median between the first half of the data, quartile 1. Does that make sense? It's also another name. Anybody know another name? And I'm running out of stuff to throw. Now I got a freaking scissors. It doesn't matter. Yes. Silly rabbit. I'll help you up. Quartile 1 is also the 25th percentile. You guys, since you're all juniors, just got all your stats back from your ACT, right? Did it say percentiles for you? It did. And I always didn't understand it. Because does that mean I scored 25%? No. It means if I was at the 25th percentile, that means I beat 25% of the people that took it, which isn't very good. Okay? This is the median. Can anybody tell me another name for the median? Quartile 2, that's a great name. What's another name then? The 50th percentile. That means 50% is above it and 50% is below it. Does that make sense? Percentile. Okay, what does this represent? That means quartile 3, which is the 75th percent data, and this represents the max. Okay, so whenever you do your box and whisker plot, what was the lowest number we had as a shoe size? 3. What was the highest number we had? So I'm got to go and write 3 through 13, because that's not too hard. Now, if it was 3 through 100, might I skip a little bit and go by 5s? Yeah, you know what I mean? But as long as it's the same increment, so you can get the understanding of what it looks like. But because I'm only to 13, that's not too bad, so I'm going to just keep going. So once again, min was 3, max was 13. Oh, did I? I don't know how to count people. That's not math. That's just counting. Okay. What was our quartile 1? 5. What was our median? 9.5. Quartile 3. Okay. That actually shows you a lot. I don't know if you guys really understand that it talks to you a little bit. Just by looking at it, it can talk to you. I have my target ready. Load up today. Oh. I'm ready. I wonder if I can get you between everybody. What are you hiding for? It's a Nerf bullet. It's not like it's going to hurt you. Watch. Ah! And then you'd be a pirate. Arrgh. Or you might get elected to Congress like the one dude. I don't know his name, but he lost his eye in Afghanistan. I do not! You're such a liar! Kylie, you shut your mouth. Okay, so let's read what some of this means, though. So this is meaning, look at this, how small this section is compared to this section. They're both 25% of the data, aren't they? Okay, because quartile 1 to quartile 2, which is the median, that's 25% of the data. Quartile 2 to quartile 3, that's 25% of the data. But do they look equidistant on our box and whisker? What does that tell us? There's more data between 9.5 and 11 than there is between 5 and 9. Meaning, there's actually not more data. The same amount of data happens between a smaller amount and that other amount. Does that make sense? There you go. Thank you. The data is more concentrated in that section. Okay? So one time I've seen the median and quartile 3 be the same number. Right? That means that number happened a lot. Does that make sense? Okay. Any questions so far? All right. The next thing I would like to talk about is what if, though, for example, I took the GRE. If you guys don't know what the GRE is, it's kind of like the ACT for grad school. Okay, you got to take this test to get into grad school. Okay, so when I took the GRE, there's a math, a writing, and a language section. And I knew my language section was going to suck a duck, so I knew my math had to be pretty. You know what I mean? And I actually did really well. I got 100% on my math. We're not going to talk about the language or the writing, though. Okay. Not so pretty. I had to be 45th percentile, and in my math, I actually got the 92nd percentile. But that means I scored 100, and I was still in the 92nd percentile. So what does that mean? 8 other people, or me and 7 other people, roughly scored 100 on that. Does that make sense? Because I beat 92 out of 100 people. No, because the data represented, that was an information. So like do you guys know your AP tests are sometimes graded as percentiles? What they do is they get their scores, right? And sometimes the test is harder one year than another, so they can't just use it off a percent. Okay, does that make sense? Usually what they do, from what I've been told, is they grade it and then they do certain percentiles. They want to stop it, like a 3 is at like the 40th percentile, let's say. I don't know exactly, but you get what I'm trying to say. And then like a 5 on your AP test is at the 70th. So if you got a 70 or higher, or the 70th percentile or higher, you're going to get a 5. Let's say you're between the 70th and the 50th percentile, you're going to get a 4. Does that make sense? That's how they work it. Everybody with me on that? And that's why your AP scores can go adjust from year to year, because the tests are different and the level of difficulty every year can be different. Right? Make sense? So this is how they do it. But anyway, I got a 92nd percentile. So we had how many just terms? 30. How would I find the 92nd percentile? Well, it's not the exact way, but this is kind of how I've been taught just to teach it for you guys, is I'm going to times it by 0.92. Okay? Can somebody tell me what 30 times 0.92 is? I guess I could do it. It's 27.6. That wasn't too hard. Now, does that mean the shoe size is 27.6? What does it mean? Well, I go back to my list. Okay, go back to our stat edit list. And then I'm going to go down to the 27th number. Okay, now notice if you guys will look right here, it says L11. Notice as I go down, look what's happening. All I got to do is scroll down until I get to the 27th number. Because it was 27.6, right? Now a percentile, what a percentile means, okay, a percentile means I will then beat that many people. I have this many people below me. So if it's at number 27.6, here's 27, here's 28. Okay, so this one's pretty easy because what's number on 27 and 28? An 11, right? So 11 would be the 92nd percentile. If you had a shoe size of 11, you're in the 92nd percentile, meaning if there was 100 people in here, you'd most likely beat 90 people. Does that make sense? Any questions on that? Now, what if, though, this was an 11 at the 27 and this was a 12? So I don't know exactly, once again, because stats isn't something that we really get into that much. So it's been a while since I've done it. If you went into stats, anybody taking the AP stats here, just curiosity, you would get deeper in how to find these percentiles a little bit nicer. Does that make sense? I'm doing like kindergarten percentiles, and you're going to get into high school percentiles, if that makes sense. I'm just giving you the basis of how to kind of figure it out. With me? Okay, so with this being the case, if this was an 11, like let's say right here, right there. So what if it was 28.6? So 28 is 11, 29 is the 12. What would I do? I'd do the 12. Why would I do the 12? Because I would beat these people, right? If I did the 11, technically there's some people that could be a little bit higher than me that would beat it. Does that make sense? So you just raise it up one. Even if it's 7.1, you go up to the next number. You look at the 8th term. Does that make sense to everybody? Now, if you're ever looking for the 75th or the 25th percentile, we've talked about that already. Remember, that's where you would actually go ahead and find the specific median between the median and the min, right? It would actually be the median. Then the median between the median and the max would be quartile 3. Make sense? Everybody there with me? We doing okay? Any of this stuff? You guys remember doing? What the hell just happened? Why are we? Has it been yellow all the time? Huh? I think yellow is better. Uh-oh. It's time to eat. Was it a text? You soccer kids, I love you. Good little soccer people. Okay, so give me another percentile and we'll do it. Let's say the 20th percentile. We can still see it, can't we? It's not nice, but we can see it. Just think, guys, less than a month. That's all I have to deal with it. The 20th percentile, so I'm going to times it by 0.20, which is the 6th number. So I go to my list, and I go up to number 6. I did ascending. I bet I could find that. I bet your calculator would do it. So for like me, I have stat sort ascending. I bet there's something in there like that. So, you know what I mean? So then I go to the 6th number. 1, 2, 3, 4, 5, 6. What is it going to be? 5. That'd be the 20th percentile. Does that make sense? Everybody get what we're doing on percentiles? Any questions on 8-1? That's 8-1 in a nutshell. We've learned that quite a bit, haven't we? Have you guys even done percentiles before? Okay, awesome. All right, next thing that we're doing. Okay, the next thing that we're going to talk about is standard deviation and variance. And I really don't know what the heck variance is used for, and hopefully in AP Stats you guys would learn that. Standard deviation, not variance. That's right. Should have this ready at all times. Standard deviation and variance. Okay, now I could get deeper, but it's actually in next time's lesson when I can get deeper on standard deviation. We're just actually going to break it very small. But remember, I think we've talked about in the past how you really don't ever want to be graded on a curve. If somebody's graded on a curve, that's not good. I don't know if you guys have, the curve that you guys are usually graded on, you're like, the highest score is now 100%, right? That's not a curve. That's just lowering your standards. But anyway, but a normal curve looks like this, and we'll actually talk a little bit about it more next time. But what it says is that 50% of your class passes and 50% of your class fails. Doesn't matter what your scores are. You find the median, those people pass, those people fail. That's what a professor did it to one of my friends. They thought it was going to be like the curve. He's like, you guys should check into your contracts before you really sign them. Anyway, because they're like, yeah, we want to be graded on a curve. Yeah, no, you don't. A true curve, if you ever have it. Now, a lot of people do what we talked about, drop the highest down to the thing, whatever. But that's not a real curve, so just be aware of that. Okay, standard deviation. What is a standard deviation? So as we just did with the shoe sizes, what was our average? 8.33, right? Right? I think it was. So what they do, the standard deviation is basically it's almost like the average distance between, like, what was your shoe size again? 10. So his distance from a 10 to the average is 1.67. Does everybody get that? 10 minus 8.33. That's how far he is away from the average. So everybody does that. Find that distance, right? And then we square them, add them all together, and divide it by 30. And take the square root. Now, you really don't care about it, but really what it is kind of like the average distance away from the average in a nutshell. Okay, does that make sense to everybody? The average distance away from the average. There is a formula. Once again, our calculator does it for you, but here it is. Standard deviation. Did she make you do standard deviation by hand? Good. It's who wants to do that. So what is this one? Do you guys remember what that symbol means? It's lambda. No, not lambda. Sigma. It is sigma, but this is the sum. You guys remember this is the sum? And what they do is they say, okay, you're taking the sum of your elements minus your average. You're squaring them. Then that means add them all together, right? And then we're going to divide that by the number of terms we have. And really what this does is it just puts it on a chart. Okay, so as I was showing you this standard curve here, the normally distributed curve kind of looks okay. It's grouped, and I'll talk about more of these groupings next time, but this is considered one standard deviation, meaning from the mean, I take this number and you're one this way and one that way. This distance is considered one standard deviation. You take it to the left and you take it to the right. Okay, does that make sense? Two standard deviations would be 2 to the right and 2 to the left. 3 standard deviations, 3 to the right, 3 to the left. Now, when we talk about this next time, it'll make more sense, but most of your data will fall within 3 standard deviations. Okay, so let's go back to it. So once again, my X bar was 8.33, right? That was our average. Now let's look at our data to see what the standard deviation is. So if I go back to my main menu here, oops, it's gone, so I'm just going to go second entry. Oops. Okay, so I have this. This was where all our data is. You guys see the one with S of X and the little mini sigma? Those are both standard deviations. So the 3.055 and the 3.00. Those are both standard deviations. The one we are going to use is the S of X. And the reason being is this is a sample. Okay, what did I ask you guys? I asked you your shoe size. So you guys are a sample of the world's population on the shoe size. So right now in Mr. Roberts' class, whoever was in here, your average shoe size was 8.33. But that's just a representation of the whole group of everybody's shoe size in the world. Does that make sense? So S of X represents a sample, which we are a sample. We're not the whole world, are we? Does that make sense? Whereas the little sigma X, the 3.00, is adjusted for kind of like, hey, this would be the world situation. Does that make sense to everybody? So once again, you're going to use the 3.055. Now on any normal test, they're not going to have both on there because it's rude to have both of them on there. It really is. So it'd be one or the other. Does that make sense to you? Okay. If it was multiple choice or something like that. Okay, well, let's talk about what this really means. Okay, so I'm going to come back here. It was 3.055, right? Was that what it was? We'll just go 3.06 to make it a little bit nicer. Agreed? Is that the number? Okay. Now, what does that really mean? Well, let's go ahead and show you. Here's my average. What was the average? 8.33. Let's do one standard deviation. So I take that number, which was 3.06, and I'm going to add it. 3.06 to 8.33 is 11.39. If I subtract 3.6 away from it, I get 5.27. A lot of our information covers from a size of 5.27 to 11.39, doesn't it? Isn't that most of our data on our list that we had? What was again our minimum value? What was it, a 3? What was our highest value? Okay, now watch in this case. If I do another standard deviation, when I add again, so once again, this distance right here was one standard deviation. Okay, now if I subtract it again and add it again, so 3.06 would be 14.05, excuse me, 45. How was that test, by the way? Uh-oh, nuts and crackers. And this would be 2.16. No, not 16. 19. 21. What the hell am I thinking? I can't even add today. Oh my. See, and there's a picture of hell, so I can. That's what I'm saying. Because somebody says it's all about commas, Mr. Roberts. Okay, so right there, that's how many standard deviations? 2 of it. Okay, does that fit all of our data? Is all of our data between 2.21 and 14.45? It is. So how many standard deviations covered our data? 2. Most of the time, I would say 90% of the time, it's going to be 3. I have only found once in any time I've done data to be 4 times. Once. It is a rarity. And when I talk about it next time, you'll understand why. Okay? But it took 2 standard deviations to cover all of our data. Now, we talked about variance. Really, guys, I have no idea what the heck variance is. I don't know what it's used for. I don't. But all it is your standard deviation squared. Yes. No, our standard deviation is 3.06. How many standard deviations covered our data? 2. Does that answer your question between the difference? Okay. I really don't know. We take 2 stats classes. And my first stats class was in 2002. So that's 17 years ago. And my other one, I could have did better on it. I started doing good, and then I had to do some more work because we were struggling financially, and I put that class off. And a C gets me a degree. That's what I chanted. You know what I mean? You guys say D minuses get you guys degrees, but in college it's a C. You can get a C minus, but it's not going to count. Right here, that's sigma. It's the baby of this guy. This is the capital sigma. This is the lowercase sigma. No, well, this means sum, right? This means standard deviation. All right. That's about it. That's 8.1 and 8.2. Yes, I can. Just because I like you, Carter. You remember we also saw this one, sigma of x. I hate drawing sigmas, was 3.00, right? Now, once again, what's the difference between the two? One's a population and one's a sample. Okay. Any questions on standard deviations, things like that? Okay. Well, I'm glad some of the sophomores are back in because now this is the time that we're going to cover the end of 10.7, the stuff that we did not get to. Okay. So right now, this is the end of 8.2. So that was today's homework is 8.1 and 8.2, but I am adding on a 10.7, which was your homework last time. That's why you guys aren't turning in today, is I'm going to add 7 more problems to it. Okay? So, 10.7, the part that, yes, ma'am. I'll hand you a packet in just a second. But 10.7 is the part that we didn't get to is equations-wise, where I gave you an equation, something like this. Okay? For r equals 4 secant of theta. If I started to plot points on this, it would actually come out to be a line. Let's figure out why it would be a line. So right now we're in polar. What do we want to do? Put it in rectangular. And putting it in rectangular means I only want x's and y's, right? Oh, I'm out of bullets. You're lucky. I shot 3 times and luckily I was out of bullets. Okay. So I want to put it in x and y's. Okay. So what I'm going to do is, well, this means 4 over cosine. Would you guys not agree with that? You guys agree with that, right? Secant's just another way to say 1 over cosine. How was your dancing last night? Good. Okay. But if you guys recall, the 2 things that we know about x and y, x is who? What does x equal? R cosine of theta, and sine is r sine of theta. That's what y would be, right? So if I times that cosine up, what do I get? R cosine of theta equals 4. Well, what is r cosine of theta? What's another name for it? X equals 4. Isn't that a line? It would look just like that. If I plotted values into r equals 4 secant of theta, it would just be a straight line. Okay? Notice I went from polar to rectangular. For those that just came in, this is some problems that we didn't get to on the 10-7. I have been recording, so on 8.1 and 8.2, you could go back and watch it and have that lesson. It's very simple. It's mean, median, mode, and standard deviation. So nothing too hard. Okay, so let's do another one. How would I get r equals 2 into rectangular? Are you guys limited on the time you have? Nice. There's a seat up here. There's one back there. It depends on where you want to sit. You're okay back there. R equals 2. What does that look like, guys? Just means our radius is always 2. So what does that look like? It's just a circle. So what do I make that that's a circle? Shouldn't that be x squared plus y squared is 4? Because our center is at 0, 0 with a radius of 2. But how do I get that from here? Well, let's think about it. Let's square both sides. What's another name for r squared? Notice that's what it is. Okay. Any questions? How about theta is pi thirds? So we don't know our radius, do we? So we don't know our radius, but our theta is always going to be what? Pi thirds. So it is going to be a straight line because it's on this angle measurement. Now, why am I going into quadrant 3? Because once again, I don't know my radius. Could the radius come out to be negative? And if he was negative, what would happen? I need to push through to the other quadrant, right? Does that make sense? So that's if your radius is positive, so if r is greater than 0, I'm going to be on this part of the line. But if r is less than 0, then I'm going to be pushed through over here, am I not? So how do I write this equation of this line? Do we by chance know a certain point that's on that line? I do. I know a point's 1/2 comma root 3 over 2, because isn't that the coordinate of pi thirds? Correct? So I'm going to come down here. I'm going to draw this a little bit nicer just because. So if that point is at, continue on with that line, notice if that point is over 1/2 up root 3 over 2, isn't this equation of a line right here? Just an equation of a line, isn't it? Even if I went down into here. What do we, oh, you guys can't see that yellow, can you? Can you see that? All right. That's blue. The first one was yellow. You guys didn't see the yellow. In the yellow. I don't know what the heck's wrong. 6 more weeks. Anyway, what do we need for an equation of a line? We have our y-intercept. Where's that at? 0, 0. And all these lines would go through 0, 0, wouldn't they? If they are a angle, right? What's our slope? Square root of 3 over 2 over 1/2, which comes out to be root 3. That equation of this line is y equals square root of 3 over x. Okay? Okie dokie smokies. What about x equaling, let's see, y equals x? What? Yes. It would be, actually. What's their slope? 1, right? So that means the x and y value have to be the same. Where on our unit circle is the x and y value the same? Pi force. Now let's show you another way how to do it, okay? So what's another name for y? R sine of theta, right? Equals r cosine of theta. If I divide that over, I get sine of theta over cosine of theta equals 1, which is what? Tangent of theta. And where does tangent of theta equal 1? Pi force. Okay. Should we try another one? Y equals x squared. What do we know y is? R sine theta equals r squared cosine squared theta, because once again, r cosine is x, but it's squared, right? So I squared both of those items. Does that make sense to everybody? Now, usually we want to solve for r. Okay? We want to solve for r. So in this case, I'm just going to divide r sine over. Actually, let's just divide the r over. So now I'm at sine of theta equals r cosine squared of theta. How do I get r by himself? Divide it over, right? What's another name for cosine squared? Don't tell me 1 minus sine squared. Just cosine, cosine, right? Cosine, cosine. What is sine over cosine? Tangent of theta. And there's a 1 here. 1 over cosine. Secant equals r. So, right there, we're in it. We have r's and thetas. Okay? Whenever you see an x squared plus a y squared, what's that again? R squared, right? Makes sense? Any questions? So for those that weren't in here, your homework on 10-7 that you're going to extend onto the one that we did last time is 33, 37, 41, 49, 61, 65, 67. Ben, you hand these out. If you need, maybe grab a little bit more. Ben's going to be handing you out your worksheets for 8-1, 8-2, 8-3, 8-4, but we just did 8-1 and 8-2, correct? Those are the only ones you need to do, as those as well. Okay? So you have the packet of 8-1 and 8-2 plus these 7 problems. Okay, and if you didn't finish last time's homework, get it done by next time, because we're going to turn it in on that one. Any questions? Okay, that's it. If you are a sophomore,